Good morning. Today we're going to look at a review of solving all sorts of different types of equations. Why don't you pause this and try the warm-up first? See if you can come up with a strategy. You might not know how to do these rational expressions, but they are just like fractions. So if we think about a perhaps smaller problem, like let's say we think about 1/5 plus 1/10, right? What would you do? Well, I see a fraction, and when you add fractions, you need to have a common denominator. So I multiply the first thing by 2, all right, to get a common denominator. And then we can just add across the tops to get our final answer, right? So we add the tops. So let's do the same process to this rational expression, right? The denominator, the first one is x and the second one is 2x. So I'm going to multiply the first one by 2 to get a common denominator. If I distribute that in, I get 2x squared plus 8. And the second fraction was 2x squared plus 1. My denominator then is going to stay the same and be 2x. So we can just add across the tops like the second step. After we multiply by 2, we can add the tops. So I'm going to combine like terms to get 4x squared plus 9 divided by 2x, which is d. So even if you don't quite know the math, always see if you can come up with a similar problem that you do know how to do. All right, so general notes about solving. Remember the fundamental theorem of algebra says that the exponent is going to give us how many solutions there could be, right? So we're going to get 2 solutions for a quadratic, 1 for linear, and we have more options for solving if we have a quadratic. We could do algebra steps, we can factor, graph on a calculator, quadratic formula. Quadratic formula works all the time, whether it's real or imaginary. Which is kind of nice, so that's a good one to know. Okay. When you see 3 terms, always make sure to set the equation equal to 0 first. So I'm going to subtract 70 from both sides. And then I'm going to think about which strategies will work. I can't use algebra steps because there are 3 terms. I could quick think maybe, can I factor it to things that multiply to 70? I don't know. That's a big list. So perhaps I'm going to graph or use the quadratic formula. On the MCAs, you are given the quadratic formula. On the ACT, you are not. So you kind of, if you want to use that option, you have to have that memorized. So to review how to do it on the graphing, right? You want to go to your y equals and make sure that everything is cleared out. What I would do before the ACT or MCA is just clear out your calculator completely, and maybe even reset it. And then type in the equation. Actually just going to hit graph. My window is from -10 to 10. If it's not, you can always zoom back to normal is zoom 6, all right? Well, the cool part about multiple choice is that you can actually just kind of estimate. This is x equals 2, 4, 6, 7, about 7, and this one's about -10, all right? And since it's multiple choice, you don't actually need to get exact values. You can kind of just say, oh, look, that's C as an option. X equals -10 and X equals 7. You can see which one is close enough. If you do want to go through it and actually calculate it, you can. Second trace, and we can calculate the 0. You want to pick a point to the left and to the right of where you're looking. So I'm going to type in +5 and over to guess that it was 7. And it is 0, 7. So you can do that, or you can just estimate. Since it's the ACT is timed, it's faster just to estimate. If you are pretty fast at factoring, right, 7, 10, 1, 70, you can kind of see that 7 and 10 would work if the 10 was positive and the 7 was negative. Those would add up to 3 in the middle. Make sure that you set these to 0 first before you solve for your actual solutions, though. So a couple options there. Solve the equation. This one, lots of options again. So I'm going to go through and show you the graphing way again, because this is probably the fastest way to solve it, especially if it's multiple choice. You can go ahead and find what's the closest thing. Okay, I'm going to guess that this is x equals -1 and x equals 2.5. All right, so multiple choice, I could just go ahead and pick the one that's closest to that. If you wanted to actually calculate it, if there were 2 options that were close, I go second trace. I'm going to calculate the 0 when it equals 0, the equation. And instead of typing in numbers, you can move the cursor. It says left bound, so I pick a point to the left of what I'm looking for, and then to the right of what I'm looking for, and then I'm going to make a guess. And it was 2.5, so right, it's pretty close to my guess. You can also look on the table, and when y equals 0 is what you're looking for, so you can already kind of see that x equals -1 and x equals 2.5. We calculated a different way. If you have a larger type problem, right? Mr. Westpatal on weekends, he likes to go play with, or he created like a little potato gun, right? It's like this thing that will shoot potatoes. It's kind of cool, I guess. That's what you want to do with your weekend. So let's pretend that Mr. Westpatal is hanging out and shooting potatoes. Okay, so here's his potato. Woo! Hopefully he doesn't hit his neighbor. Got some. Oh. There, Mr. Westpatal with his potato gun, shooting the potatoes. And we want to see if it could go over a tree that is 50 feet tall. All right. So basically it's asking you for the maximum height, which is also known as the vertex. It is an XY coordinate pair. And if X is time, height, it's looking for Y. What is the Y height at the vertex? There's a few options we can do for this, and we're not actually solving it. Is it possible that it goes over? Solving gives you the intercepts. It's not, no, that's not right. It's asking for the vertex, the Y value of the vertex here. Is it possible this potato could travel over the top of the tree? Yeah. My picture makes sense. So draw a picture so you know what it's asking. It's not asking you to solve. It's asking you to find the vertex. And so I'm going to type this into the calculator. I want to show you a couple things. If I hit graph, I can't really see it, right? Which makes sense because we're trying to figure out up to 50. Like, does it go all the way up to 50? So you might want to change your window if you want to see it all the way. We're looking along the y-axis higher, so I'm going to make the y-axis go up to 60, and that way I can see it a little bit better. All right? Let's make sure I typed in my equation correctly. And t6 121, so it's going to crash into that tree. So I got 121. And one way to do it is to look at the table, see how there's symmetry on either side, like 5 and 5. The middle value is 121. That means that's the maximum or the vertex. We can look on the graph too, and if we were to just trace that, we don't have to actually calculate it. We can see that it doesn't get past that 50 feet. So we're gonna crash. So the answer is no, it's not possible to go over that tree, because it only goes as high as 21 feet. Okay. You could go ahead and calculate it if you wanted. It is a maximum, and you could do that left, right, center thing again. So enter to the left of the point you're looking for, to the right, and then on the center. And it's 121, which is what we found already. Don't get caught up in all the solving. Some of them you just want to use order of operations. This is a linear equation, so I'm solving for x, just written crazy. So remember to go through your order of operations. Okay. First, we're going to deal with the parentheses. So you get 5x plus 10. That's the left side. I'm going to combine like terms. 5x subtract 4x is 1x, and then plus 15. And then let's go ahead and look at the right side. I'm running out of space, so I'll erase my pen pass. If I distribute this 10 in, you get 10x plus 60. And now we want to move everything to the same side. So I'm going to subtract 1x first. And then subtract the 60. And then divide by 9. X equals negative 5. Right, so just remember, I guess this one would be a gentle reminder for parentheses come first. Right. When you're solving to like move things around, it kind of goes backwards there. All right. Absolute value is unique. There's no exponents. It actually kind of defies that fundamental theorem where like you're looking for the exponent. There isn't one. The absolute value does give you two solutions. So if you remember that, you can already kind of think about two of them not working. Okay. Why are there two solutions? If I start solving this, I want to first isolate the absolute value. Right? And so you get 3x minus 2 on one side equals 4. Now inside of there, it could be the 4, right, would equal 4, or it could be negative 4. Right? Both of those solutions would work. So I'm going to take that 3x minus 2 and set it equal to 4 and set it equal to negative 4 in order to find my two solutions here. The steps for solving are going to be the same in each case, but you're going to end up with two different solutions. So when we divide by 3, you get x equals 2 and x equals negative 2/3. So be careful with absolute value because there are two options for that answer. Square root. What you want to remember for this, again, these are kind of like fun little solving things, is that if you take the square root of x squared, those are opposite operations. And so to get rid of the square